plus 3 times y1 plus y2 and y3. So here this is the result for the integral starting from x0 and going to x3 fx dx. And as we have been doing in the previous two cases, to extend it for the entire domain, so here we can extend this result for the entire domain of x0 to xn fx dx. So this can be split it up into the subintervals form, and each of length 3. So the first interval is x0 to x3 fx dx. Next is x3 to x6 fx dx, x6 to x9 fx dx, and many more integrals you can write down, xn minus 3 to xn fx dx. After doing this, the next step is to bring the values. You can see this is the value for the interval from x0 to x3. A similar kind of result for this and so on can be written down. Okay, after writing or substituting the values, we get 3 by 8. Inside this is y0 plus 3y1 plus y2 plus y3 is the output for the first integral. For the second integral, this will be 3h by 8 outside, and it starts from x3. You can see here it starts from x0, we take it y0 here. So here we have to take y3, and in between x0 to x3, x1 and x2 are, we have replaced the y1, y2 by multiple of 3. So here we replace 3, y4 and y5 with the multiple of 3, and y6 will be out. Now for the third integral, a similar pattern result can be written as y6 plus 3 y5 y6 y7 and y8 and plus y9. And you can go on the same pattern, 3h by 8, and the result can take the form yn minus 3 plus 3 yn minus 2 and plus yn minus 1 and plus yn. So these are the results you can obtain after replacing the integrals with the this result. Okay, so this gives you the ultimate form. You have to keep it as it is. Otherwise, the one more step you can do to take out 3 by 8 as a common factor, and then you can join the similar terms together to write it in a more compact form. So these are the three formulas we derive for the numerical integration. One of them is the trapezoidal rule, second one is the Simpson's 1/3 rule, and the third one is the Simpson's 3x rule. Let me summarize all these formulas here. Okay, the first formula is the trapezoidal rule. The integral from x0 to xn fx dx can be written as h by 2 y0 plus 2 times y2 and so on yn minus 1 and y. So this is the formula for the Simpson's trapezoidal rule. The second formula is for the Simpson's 1/3 rule. The formula for this case is x0 to xn fx dx is equals to h by 3. Inside there are the terms y0 plus 4y1, y3 and so on, yn minus 1 plus y 2 times y2, y4 and so on, yn minus 2 and yn. So this is the formula for the Simpson's 1/3 rule. And the third formula which we have just derived is named as the Simpson's 3/8 rule. And the formula for this case is x0 to xn fx dx equals to 3h by 8. Inside there are terms y0 plus 3y1 plus y2 plus 2y3 plus 3y4 y5 plus 2y6 plus 3y7 y8 and many more terms you can write down, yn minus 2, yn minus 1 and yn. So these are the three formulas which we have so far derived and I hope you can memorize all these formulas, or you can write them on a separate page whenever you are going to solve the questions, so those will be helpful for you. Now the next step is to apply these formulas in order to solve the question. Before starting solving the question, regarding these two formulas, this formula is applicable for those set of points which contains even number of intervals, and this formula is applicable for intervals of multiples of 3. And this formula is applicable to all kinds of intervals. So these are the things you have to keep in your mind while solving the questions. So here we start solving the few examples. The application of these formula is not very complicated. It is very simple, and you will see the calculations are only few lines calculations, and you can obtain the results within few calculation steps. So here we are given an integral. It is in between the interval from 0 to 10 dx over 1 plus x. We have to apply all the three methods or three formulas we have so far seen. Here the h is also provided to you. Sometimes it is not given, you can then decide about h of yourself, but generally it is given in the question whenever you are solving. So here h is 1. It tells you the interval from 0 to 10, you have to divide it by taking an increment of 1 unit each. So here we divide this interval here. We gather few informations. x0 is 0, xn is 10, h is 1, and the function which we are going to integrate is 1 plus x square. These are the information we gather from the given question. Next step is to construct the table of values. For this, you have to keep it in mind you are going to divide the interval with an increment of 1 unit each from 0 to 10. So here we take x and the corresponding value function, a function which is 1 over x square. So let's construct the table. The interval starts from 0 and with an increment it goes to 1, then 2, 3, 4, 5, 6, and let me write it on this side, 7, 8, 9 and 10. Okay, now you have to put 0 over here, we'll be getting 1. On putting 1, so it gives you 1 by 2, means 0.5, or you can keep it 1 by 2, it depends upon you. Next is, if I replace it by 0.5, it will be better for calculation point of view. Next is, on putting 2, it gives you 1 by 5, 1 by 5 is 0.2. The next is 0.1, you can verify it of yourself. So the next is 0.0588 and 0.0384, and next is 0.0270, and next is 0.02, 0.0153, or we can write in 4, 0.5, sorry, the 0.012, 2, and the last one is 0.0099. So these are the values we obtain after substituting them into this formula and dividing the interval into the subintervals of length 1 each. Now, in order to apply the methods which we have so far learned, or the formulas we have so far learned, you have to label these values. This is important here. This is your y0, y1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This will be helpful whenever you are going to substitute them into the formula. So you have to not go through where the respective value is present and you have to select. So this will be helpful there. Now we solve them for the trapezoidal rule. The first case we are going to consider is the trapezoidal rule. And the formula which we have derived, and that was for n number of intervals. You have to redesign the formula, you have to rewrite the formula according to the number of points given to you, or number of intervals given to you. So here we have, you can see from 0 to 10, there are, you can count them, how many intervals are there. Accordingly, you have to write the formula, okay? So here we write it in the form of x0 to x10 fx dx, each by 2 times y0, the first term remains as it is, and inside, in between the terms are multiples of 2 up to y9, and the last term is y10. So this is the redesigned or rewritten formula. Previously we have written it for the endpoints, now we are using the only 10 points. Okay, now next step is to put in the values. H is 1 by 2, y0 we can get it directly from here, 2 times y1, 0.5, 0.2, 0.1, 0.0588, and 0.0384, 0.0270, 0.02, 0.0154 from here. Next is 0.0122, and the last one is 0.0099. Okay. We have just substituted the values in the corresponding places, and okay, now you can use your calculating devices and simplify it. On simplifying this result, you will be getting 1.4768. This is going to be the answer.